Okay, everyone, the impossible puzzle solution. Basically, I chose to make a square 120 millimeters by 120 millimeters. And by making this puzzle work, we have to make sure that the length of this green piece on this edge matches the length of this blue edge here. The length of this blue edge here matches the length of this green piece minus this length of this yellow piece, which is 10 millimeters. So in other words, the measurement of this edge here is 90, and the measurement of this piece here is 20, and the measurement of this piece is 10. Therefore, if I take 9 and I add 1, that becomes 10, and I add 20, that becomes 120. Therefore, I get 120 going down the edge if I move the blue piece to the corner. And if I move this green piece to the corner, it should match onto that one, which is basically 70 millimeters. And on the blue edge over here, it's approximately 70 millimeters. It's 68.57. It's very close to 70. Now, the reason that this piece here doesn't match that piece there is due to this angle of the triangle. If we change the angles ever so slightly, these lengths change simultaneously. So it's a matter of fine tweaking this line here to try and match these lines as accurately as possible. So now what happens when we shift the pieces over here? I'm going to move the pieces out of their orientation for the moment to show how all the pieces slide into place. So, alright, let's start with the blue piece. We shift the blue piece here, which is 90 millimeters going down. We have 20 here. We take this piece, we add it in here, and we get our 120 going down the bottom. 120. We then take the green piece and mount it on this corner here. And voila, here's the puzzle with the square in the middle, and as you can see coming down on the bottom, you can see the differential that's been created because of this the line from the triangle not being perfectly square. And we measure this difference. It's 1.4286 millimeters, and the base of this big green piece is 70 millimeters. If you multiply these two values, you'll get 100 millimeters square, which just so happens to be the area in this square here, which is 10 millimeters by 10 millimeters, giving 100 millimeters square. So that's the solution pretty much. I could show you down to this edge. It's 121.4286 millimeters, and the top is still 120 millimeters. Now, the reason why this looks like magic, pretty much, is that you cannot see the small difference here of 1.4 millimeters.